All right. So yeah, today we're talking about transformation, and this isn't necessarily related to animation, like they don't have to go together, but since we were looking at animation, we can also apply animation to our transformation. So um, for transformation, uh, we get to do some stuff with the canvas to create some new effects that we haven't been able to really achieve previously. I'm going to open up my editor and start a new project in case I want to demo anything. Um, so what transformation refers to is transforming the actual drawing context itself. So what I mean by that is if I run this sketch, we have this like this canvas here, and most of the time we are simply just like treating this canvas as a 2D space that we that we can draw shapes on. So if we draw a shape uh, in the middle or at 0, 0, we might draw like a rectangle like right here or something like that. And what transformation does is it actually, instead of changing what we're drawing on the canvas, it changes the canvas itself. So we can kind of think of this canvas as a bit of a window. And it's sort of like a window inside of our HTML document to this rendering context, which is like a big fancy word for saying like where we draw stuff. And that rendering context actually extends beyond like what we can see. We kind of got a sense of that the other day when we were doing animation, when our circle was like half inside and half outside the rendering context. So there's stuff out here that, even though we don't see it, theoretically exists if the x value is over here or something like that. So with transformations, we can transform the canvas itself. So one example of that, one main thing that we can't do in with our regular shapes is doing a rotation. So if I wanted to draw this same rectangle but rotate it around like this, you could, figure out what are the points of this shape and draw like a vertex or whatever, but you wouldn't be able to just rotate based on a rotation. So that's what transformation lets us do, is it essentially lets us take the XY axis. So this is the X and this is the Y. And the 0, 0 is like right here in the middle. And what transformation lets us do is we can transform different aspects of our canvas in space. So we can translate, we can move 0, 0. So we could move 0, 0 down over here. We could move it over there. We could move it up. We can move it wherever we want. And that changes what we'll see if we're drawing a rectangle at 0, 0, but then we move 0, 0 all the way down here. Suddenly we'll see the rectangle down here because our canvas, our window doesn't change. So we're changing our canvas, but we're not changing this little window that looks into the canvas. So similarly, if we, rotate around, we'll rotate this rectangle around to, here or wherever we rotate. And then we can also zoom in. So we could zoom in here and suddenly our rectangle would get much bigger, or it might even get smaller if we zoom out. And then we can also do some other types of transformations that we'll look at. And this is all in 2D. You can actually do 3D transformations in P5 as well, but that's a whole other topic that we won't get into today. But anyway, let's look at some transformation. So translate is moving the origin to a new point in the canvas. And if you click on here, you can see translate. And so here we see translate 30, 20, and then the rectangle is being drawn at 0, 0. So we can see this rectangle isn't in the top left corner, which means that our canvas has been translated. So let's see an example of that in here. So if I draw a rectangle at 0, 0, there we've got our rectangle in the top left corner. And now I can move that rectangle without changing the coordinates by doing a translation. I can say translate to 100, 100, and now my rectangle has changed. And there's an advantage to that, which is that now I could draw a bunch of stuff and then move all of that stuff without having to change these individual values. So everything that comes after a translate function will be translated. So if I also had an ellipse in here or a circle, that circle is going to be where our translation went to. But if we draw stuff before the translation, that this circle is still in the default translation for our canvas. So our translate functions work just like our fill and stroke functions, where they only apply to things that come after we write the translation. And so you can see an example of this here where I'm translating X and Y, and whatever value I translate X to, my drawing moves along with it. So you see the original in the top left, and then 0, 0 is moving to wherever I kind of move this slider to. So here's another example where the same ellipse is drawn each time with x0, y0, and size 100. But because we're using translate, each ellipse is in a different place. Oh yeah, the other thing about this example, I don't know why this is being so slow. The translations are also additive. So this translation down here actually moves from the first translation. So let's show an example of that. So in this case, I'm translating to 100, 100, which is like right down here. And if I translate again, let's say I translate to 200 and 0. Okay, so this 200 is going to be added to X from the previous translation. So the previous translation was 100 here, and so it's going to go 200 across to here. But if we do 0 here, then Y won't change at all. So let's draw another rectangle at 0, 0, 100. And so now we see that other rectangle over here. So the translations are not, it doesn't go from 0, 0 every time. The translations get added together as we add more of them. We can also rotate using transformations. So the rotate function takes an angle, and that angle is measured in terms of pi. So usually with angles, we tend to think of things in degrees. So like 0 to 360. But in math and in programming, we usually do rotations in terms of what's called radians, which are numbers between 0 and pi. So you can actually translate between radians and degrees using the angle mode function. Usually I just use pi because it helps remind me that I'm using a rotation, but you could do it either way. So let's go back here, and again, our transformations are additive. So if I put a rotate below translation, it's going to happen after the translation. So let's say I rotate by let's say pi, uh, we'll see that it flips my rectangle around. And actually, let's do a smaller thing. So there's a lot of pi's that are built into P5 since we use them a lot. So we can also use half underscore pi, and that'll give us half of a rotation. And we can even do quarter underscore pi, which will give us a quarter of a rotation, which is, it's the same thing as saying pi times 0.25. So that's actually kind of like easier to write, but quarter pi also exists. So either one of those is fine. Let's put quarter pi back in here. So again, if we rotate after we translate, we can see that it's rotating around this point that we translated to here. But if we rotate before we translate, now the rotation is going to occur before we do the translation. So what's going to happen is we're going to rotate first. So in this case, let me draw on here. Let's see. So in this case, we start here when we translate to 100, 100. So this is 100, 100. And since we switched our rotate first, Now we're rotating by quarter pi. So we're rotating like that, basically. So this creates a new rotation for the x-axis. We can see goes out this way. And then we're translating. So now this translation of 200 occurs here. So the order for these transformations is very important. So again, if I switch this back, if I rotate down here, now the translation happens first and the rotation happens second. So it's important to keep that in mind when we're using transformations. And here we can see the rotation. Again, it's relative to where we translate. So if I translate first and then rotate, it's always going to rotate around the origin. So depending on how you want your shape to rotate, you might need to draw your shape around the origin or behind it or next to it or whatever it is. So yeah, as I mentioned, we use pi to represent a half rotation. 2 pi is a full rotation. Half pi is a quarter rotation, and a quarter pi is actually an eighth of a rotation. So here we see a bunch of rotations. So we translate to 200, 200, and then we're rotating around that point. So we can also scale. And scale just kind of zooms in or zooms out of our canvas. So we can see the default scale is 1. And if I scale up, I'm zooming into that origin point. And then if I scale down, I'm zooming out. So again, the translation matters here. Normally, if we had like our default 0, 0, we'd be scaling into 0, 0. If we put our origin in the middle somewhere, then we'll be scaling into that point. And you can also do like multiple scales and multiple translates, so you could theoretically zoom into lots of points. Um, but that's the basic of how it works. So here we're just scaling. So this is one drawing, and then we scale by 2, and we see the same drawing zoomed in, and then scale by 3. And in this case, the origin is our zoom point. So our shapes are not, directly in the center, which is why they start to move away from the origin point as we scale in. Shear is a little bit more complicated. So, you can get some cool effects with this, but it's a little bit harder to understand. A shear essentially it uses an angle and it pushes the points of a shape away by the amount of that angle from the axis that we're applying the shear to. So that might be hard to understand, but you'll see what I mean. Here's shear on the x-axis. So as I increase this value, we can see this angle around the x-axis. And what we see is that with our default shear at 0, notice how on the x-axis, these 2 points are on the x-axis like normal, and these 2 points down here are the same values. And as we shear, the 2 points that are down here away from the x-axis, they start to move away from the origin. And so this, again, depends on the translation. So if I translate my shape, it's going to move along this new sheared axis. And if we increase the rotation, eventually we go back around to the beginning. And we can go negative also. So this works differently on the x and y axis, but the effect is pretty similar. So here's shear y. So now when I shear y, it's the same thing, but now notice that the points that are staying the same are the ones that are in the middle of the y-axis at 0, 0. And the points that are moving away are the ones that are down here. So we're getting a similar effect, but just with a different axis. So it's a little bit hard to understand, but you can see it just kind of deforms. It adds this angle to the axis. And it's kind of fun. It kind of makes it look like a little 3D almost, like we're getting this kind of like 3D perspective on things. And it's a fun one to use for some animation. Um, Here's an interactive example. So you can see 2 different ellipses that both are mapped to shear. One is X and one is Y. So if I go down, on the y-axis, we're mapping this first ellipse, and we are shearing on the, wait, let me read the code again. Okay, so the first one is mouse X and the second one is mouse Y. So the one in front is the mouse Y one, and we're shearing Y. And then the one behind is mouse X, and we're doing shear X on that one. So you can create some kind of cool effects. And this also uses pi as the default measurement. Okay, so to make things just a little bit more complicated, let's say we are doing some transformations, but we don't want to keep a transformation. Like let's say I'm happy with this thing, but then I want to go back to the beginning to do something else. So how would we do that? We can use a couple of special functions called push and pop. I'm gonna get rid of this circle up here just to make this a little bit easier. So now, if I want to draw something else, let's say I want to draw another rectangle, but I don't want it to be rotated. Uh, so there I have the same exact rectangle. So let's say I want to move this back to the origin. One thing that I can do to get that back is use push and pop. So if I use push here, it's going to push anything that comes afterwards onto this invisible stack or list that P5 is keeping track of for us, of all of the transformations that we've done. So if I push and then pop, what's going to happen is our rectangle goes back to the origin. So basically what's happening here, again, it's a little bit tricky to understand, but when I push, I'm basically, we can imagine that P5 in the background has this little stack of transformations. So let's say just like normal, like a default transformation is like the first one on the stack. And then when we write push, we're basically making a new little box in this stack. And any translation or transformation that we do in here is getting added into this box. So translate gets pushed into this box. This translate gets pushed into the box, and this rotate gets pushed into the box. And this keeps happening until we do another push, which we're allowed to do. We'll do that in a second. So we could push another one on top. But until we do that, this is still at the top. And when I say pop, that just pops this one off the top. It just disappears. And so we go back to our default. So again, we can do this more than once. So let's modify our code a little bit. So we can push and pop twice. So I'll say push and pop, and then push and pop again. And so now we have a couple different transformations. So let's look at what's happening. So we have our default. I'll draw this over here. This is our stack. You can think of it as like a stack of pancakes. So here's our default, and then we push once, so we make a new element in our stack. And then this translate goes in here, and then we, oh, I popped here. Yeah, I guess we just, in this case, okay, we'll do another example. I forgot. So then we pop this one, so then we just got rid of this one when we did the pop. So then we do another push. So this one is gone, and so our stack goes back to default. And now we push a new one up here, although this one is gone, so ignore that. And translate goes in there, rotate goes in there, and then we pop again. And so then we get rid of this one. And now we're back to default down here. So for the first one, we just translated to 100, 100, and then we went back. And for the second one, we translated over here to 200, and then we rotated around, and then we popped, so then we went back. But we can do it in a different order, so making things even more complicated, we can not pop here, but let's pop twice down here and run that code. Okay, so now what we're doing is we're starting with our default stack, and then we're pushing a new one, and we're putting a translate in there, and then we're pushing another new one, and so there's a translate and a rotate in there, and then we're popping this one, and then we're popping again this one, and we go back to default. So we start at 0, 0 here, translate to 100, 100, and then push a new stack, translate over here to 200, and rotate around. And then we pop both. So we go back here, and then we go back here. And you can do this as many times as you want. It starts to get a little bit complicated, so you don't really need to do this unless it's necessary. But there are cases in which you'll want to do multiple ones, and we'll see an example of this in a couple weeks of a way that we can use this and do a lot of pushing and popping. So yeah, that's another thing that we can use. Uh, do, do, do. So here we are using push and pop in order to have two different rotations happening around different points. So we would need to use push and pop if we want to have like rotations that are happening in different parts of our canvas. Like if I want that rotated over there and this rotated over here, I'm going to want to use push and pop for that. And let's look at this. Okay, so yeah, we see some rotations and then a push and pop here as well. Okay, so last bit, animating with transformation. So we're gonna look at how to animate these values. Um, any questions before I go into the animation bit? All right. Let me know if you guys do have questions. So we're going to animate these things, but we're going to do it in a very similar way to how we did it with our animations on Monday. So here's a really simple example where we're just rotating this rectangle in space. And so we translate first here to get to the middle of the canvas, and then I'm just rotating according to the frame count. So it's just going up by one. This is kind of the same thing as if I had like, R plus plus every frame. Um, and I'm just multiplying it by pi, so it's measured in terms of our radians, but you don't have to do that if you just, kind of use the right units. Um, And then I'm using shear to animate some text. So we get kind of a similar effect. We see this one's kind of slow, but you can see that it's animating over time. And the nice thing with the rotation is that we actually don't have to reset it ever, because once the rotation goes around to 0, it just kind of starts over, even though the value continues to go up. So doing a animation with a rotation is a little bit easier than doing one with size or position. But we'll do a couple examples. So I'm going to grab my meme and do a couple examples of this. So let's save this. And I'm just going to open another editor window. And I'm going to open my meme rough draft so I don't have to deal with all of the stuff that's inside um, the interactive meme. Where's my meme rough draft? Image example, maybe. Okay, that's my fish image. Okay, maybe I need to open my meme and I'll just delete where's conditionals example? I need to use better. No, this is not the meme. Okay, so maybe I'll have to use my interactive meme. Oh yeah, I have my hamburger and my fish. Okay, so I'll use this, but I want to add animation to it. Maybe I can leave some of the code intact. Hopefully it won't get too complicated. If it gets too complicated, I'll probably just delete some stuff. But anyway, let's save this as a new copy. So I'm gonna go to File and Duplicate, and I'll call this meme 3. animation. And actually, I don't really need to worry too much because I think I'm only using, yeah, I'm only doing image and text. So I can apply my transformations to these two functions without even paying attention to the rest of this stuff. So it shouldn't be too bad. Okay, so let's change this one here, mean version 3. Um, meme version 3, uh, animation, and the date is the 26th. Okay. So I have all my image sources, so I don't have to worry about that. I'm going to ignore most of this code up here. Uh, there's my like little counter. There's my preload function. That's setting up my text. Here's a bunch of stuff that I don't really need to worry about. Okay, so let's go down here and let's do some transformation. So I'm going to start with the text, and I'm just going to animate the text. I'm just going to rotate it. So if I want to do a rotation, as I mentioned, it's a little bit easier to do this. I'm not going to use the frame rate or the frame count because it kind of feels like cheating. I'm going to make a variable for this. So I'm going to make a new variable in my global variables called R. And I'm just going to say this is my rotation for animation. So I want to make this a global variable because I don't want to have to reset R every time. And then I'm just going to increment R and then apply a rotation. So to do this, one thing that I need to do, and we'll see this in a second, I'll change this in a bit, but we're going to have to actually translate here to get our rotation to work correctly. But let's just add it in and see what happens. So I'm going to rotate by R. And then after I draw my text, I'm going to increase R. I'm going to say pi times 0.01. So I want it to go kind of slowly, and then I can make it faster if I want. So I'm every time I draw, I'm taking the value of R, and then I'm adding a very small angle to it, 0.1 times pi. And so it should rotate around pretty slowly. It's not too slow, but you can see it's rotating. Let's, and then we see that it comes back around. So this might work depending on what you're working on, but this looks a little goofy because most of the time we can't actually see the text because remember, we're rotating around the origin. So even though my text is being drawn right here and it like takes up this space, we're actually rotating around the origin up here, which is why we get this big arc where the text is mostly not in the frame. So when we're doing rotation, if we want to fix that issue, we need to do a translation first. So what I'm going to do is translate to the position of the text, which I can just copy from here. And then we're also going to need to draw the text at 0, 0 so that it's drawn in the right place. So let's draw our text at 0, 0. And so now we have the rotation around the origin and the text being drawn at that origin. And so now it's actually kind of like clipping at the bottom of the screen. So let's like move it up a little bit. Okay, there we go. So we've got a nice little rotation. There's a lot you could do with this. Like right now, as I mentioned, it's only ever going to go in one direction because our rotation, it's even though it keeps getting bigger and bigger and bigger, it looks like to us that it's just rotating around the same circle. So we don't really have to worry about like resetting it or changing the direction. But if you wanted to change the direction, maybe after a full rotation, we would want to set it back in the other direction. We could do that. So let's do that real quick, and then we'll do one more animation. So we could have a rotation speed. So let's say variable r speed. And for now, let's just set it to what we had before, 0.01. Um, and that's pretty obvious. I don't really need a comment for that, r speed. So we could say, instead of times 0.01, we could say times r speed. And if we hit a certain angle, we could reverse r speed. So we could say if r, let's just say greater than pi times 2, or we could use 2 underscore pi, which should be one full rotation. Then we will say r speed, And we'll use the same thing we did on Monday with our DVD screensaver, r speed times equals -1. So that'll reverse the direction. So you don't have to do it this way, but if you wanted to get that effect, this is how we would do it. It is going to keep just going to the left. So you might have already realized this, but once we go back, r is not going to get greater than 2 pi because it's going the opposite direction. So eventually it's going to get less than 0. So just like we have with our canvas, we can say or r is less than 0. And then we'll get a nice little kind of pinwheel animation. It is a bit slow, so let's speed it up a bit. I'll do like 0.0, let's do 2.5. See how that goes. That's pretty good. And so now, even though I can change the text, um, the uh, animation stays the same. So the text and the animation are not really related to each other at all. So this meme is getting pretty wild at this point. So let's animate one more thing, and then we'll be done with this bit. So since we're animating the text, let's animate the image as well. And I forget. Oh, when I do click in, it makes the image bigger. So we may have to get rid of that because what I was going to do is actually animate the scale of the image, but it might just look even wackier. So let's give it a try. So I can always take it out if I need to. I think it's just right here. Yeah, I'm doing with. Okay, so we might take that out in a second. Okay, so let's animate our image. And so what I'm going to do is scale the image up. And so I need a value for this and a speed so I can toggle back and forth. So I'm going to say variable s equals 1. This is our image scale. And variable s speed equals, let's do also 0.01. And that's the image scale speed for our animation. So now with our image, we're going to have a similar issue. So let's say I just scale. I'm just going to scale by S. And then after I draw the image, I'm going to increment scale. So I'm going to say scale plus equals S speed. Okay, so now our fish image is going to get bigger. So notice a couple things. One thing is that our origin, just like with our rotation, our origin is in the top left. So even though our image is like here, it looks like it's going this way because the whole canvas is scaling outwards from here, not from here. So just like in our rotation, if we want this to look a certain way, and again, you don't have to do it this way, but this is just what seems like it should be the case to me, is we are going to have to translate to where we're drawing the image. So we're going to add in another translate function. We're going to go to where the image is being drawn. So width over 2 is the x. So let's paste that in. Whoops. Width over 2. And the y is height over 2. And now we have to draw the image at 0, 0 for this to work. Okay, so now our image is scaling up. So that looks pretty good, but notice what's happening is the text isn't there, because our text is translating even further away. And so this is where push pop is useful. If we don't really want our text to be translating along with our image, we can use push and pop here. So I'm going to wrap this whole section. I'm going to push it at the top and then pop it at the bottom. And so now the transformation of our image does not affect the transformation of our text. And I don't have to do push and pop for this one because it's the last one. When we go back to the beginning of the draw function, our context is returned to the normal transformation. So we just have to do it up here. So there we go. We can now set this to go backwards once it gets too big. So we can say if S is greater than, let's say we don't want it to scale over 3 times the size. So if S is greater than 3, or let's just put it in already since we know we don't want S to get less than, let's say, let's say something small but not 0, because if we say 0, it's going to like invert, which we don't really want. So let's say 0.1. That should be good enough. And then we'll say s speed times equals -1 to get our nice little animation. Okay, so maybe 3 is too big. Yeah, 3 is too big. Let's do 2. Also, this is a matter of personal preference. You might think that scaling to like 100 is cool. Uh, oh, and then it gets really small. Okay, I don't even want to go past 1. I just want to scale back to the normal size. So let's try that again. Okay, so now we have a really goofy meme. Let's speed this up just a little bit. Let's say 2 point. No, that's gonna be probably too fast. Yeah, that's way too fast. Let's say 125. There we go. That's even a little too fast. Let's say 0.5. Okay, that's pretty good. And then when I click, it still kind of does this like jump thing. So that's a little too crazy. So let's just comment that out for now. Okay, so now I have this like scaling in and out image and a rotating text. Now it kind of looks like a little too over the top, um, but that's okay. Okay. So this looks pretty good. I think I'm just about done. Sorry that took a little bit longer. Um, let's see. I'll stop recording here.